Am I audible? Kindly let me know in the chat box. Okay, I will wait for a few minutes and then we will start. We'll start at 8:05. Okay, after 4 minutes. Currently, I am not speaking. That is why it is not audible. Okay, we will start in a few minutes. Okay, this is what we discussed in our previous class. Okay, in our previous class, we discussed all the logic that was for sorting, right? And in today's class we are going to see the practicals, that is our programming part. Today we will see program for all this that we discussed in the previous class: bubble sort, insertion sort, selection sort, merge sort, and insertion. Okay, see, you can't submit your project in py file. What you can do is you can create a GitHub repository. There you can upload your project and share its link in the assignment. You can submit the link through a document, PDF document. Okay, and that way we can check. Make sure the GitHub repository is public. Are you all ready to start with today's class? Today we are going to discuss the programming part of sorting. The attendance link is live in the chat box, so kindly go through it. You can use Google Drive as an alternative to GitHub. Okay, upload your project on Google Drive and share its link in the assignment part. Okay, so I'm starting with today's session. Till then, make sure you are marking your attendance. Okay, do not forget to miss it. Moving on. Today will be a short class. I will try to sum up it quickly. Okay, already we have had 3 classes today, so I don't want to stress you all. After all, it's Sunday. Okay, it will be a short class, and then you can all have your dinner. So for that purpose, I have already written the programs, and now we will discuss how these programs work. We will discuss the logic behind them, and in case if you have any queries, I am going to solve it. Meanwhile, if you have any doubt, you can let me know in the chat box. Okay, so now I'm starting. First of all, we have the program for bubble sort. I hope all of you remember what bubble sort is. Okay, in the last session we discussed all these. So to save time, I'm not going to go into the details of this as we have covered it in the previous session. But in short, bubble sort algorithm, the first element is compared with the next element like this. Okay, as you can see in the diagram, 9 is compared with 8, then it is shifted. Now again it is compared, is shifted. Now again it is compared, shifted. This way it moves on. So how do we program that? First of all, we define a function and using the def keyword, and name we have given as bubble sort, that is taking one parameter, our array, which is the list that we want to sort. Okay, this, as you can see here. Is the screen visible or do you want me to zoom in? Yes, you can build a chatbot, that would be really great. Apologies. I have zoomed in now. Okay, so moving on. Yeah, first we have created a user defined function. Okay, moving on. In the next line here we are using a for loop. Okay, that iterates from the end of the list towards the beginning, right? The loop starts at length of array minus 1, which is the end point of the array, right? The last index. Len is the function that we create that we use to find out the length of the array, and -1, which means the last index of the array, right? We did that because we are not sure what is the size of the array that we are using, right? That is why we are using len array -1 to indicate to the last index of the array, and continuing down to 1. The -1 at the end at the end indicates that the value of n decreases by 1 after each iteration. Okay, after each iteration of this for loop, we decrement it by -1. That is how we are going through this array in the opposite direction from last to first. Okay, the reason for this is that after each pass through the list, the largest element is guaranteed to bubble up to its correct position, so we can reduce the number of comparisons in subsequent passes, right? Now in the next line, this inner for loop, okay, this is inner for loop. Inside this for loop, this is outer for loop, this is inner for loop. This inner for loop goes through the list from the beginning. Okay, this is the opposite. Now it goes from the beginning, that is in index 0 to n minus 1. Okay, it compares adjacent elements to see if they are in the correct order. As we discussed here, okay, we need to compare each adjacent element, right? So that is what we are doing here. Okay, it compares adjacent element to see if they are in the correct order. Now using if condition, if statement checks if the current element, that is array and the index I, is larger than the next element, that is I plus 1, is larger than the next. Okay, if so, they are in the wrong order and they need to be swapped. Okay, if this condition is met true, then we use swapped equals to true and it will be swapped. How? So the when the elements are out of order, the swapped equals to true. This line indicates that a swap has occurred, although this flag is not the code. Okay, this is just used here. The next line swaps the two elements using Python's shorthand for switching variables. Array I and array I plus 1 are swapped in this place. Got it? This was our small program for bubble sort, and this is below we have our sample list. This is our sample list that is being passed to our function. Okay, first of all we are printing the unsorted list. Print unsorted list is and print. After that we are calling our function that we created above and passing our argument parameter, and then we are printing it. So when we run it, first we have the unsorted list, then we have the sorted, right? Is there any question till now? Okay, swapped equals to true. Explain again. Sure. So what is happening here is, if as discussed here, okay, in bubble sort we compare each element, adjacent element, right? So if the adjacent element is bigger, this one, as in this case you can see 9 is bigger than 8, right? So we need to make a swap, right? We need to make a swap. 8 should come here and 9 should come here, as we can see in second step. So that is what we are doing here. Okay, if condition, you can see if array I is greater than array I plus 1, right? if this condition is going true, that is what is written, swapped equals to true. If this is coming true, then we are need to swap it, right? This line indicates that a swap has occurred. The next line that we have here, this line swaps the two elements using Python's shorthand for switching variables. You can see array I and then comma array I plus 1, then equals to, we have switched its places, array I plus 1 and array I. This is how we have swapped them. There is one more method you can use to swap, which I think you must have used in while learning C++ or Java or C. That is using a third element or so. Yes, it works on condition of if element. Attendance part 1 has been completed. Moving on to our second program, that is for insertion. Okay. We also discussed insertion in previous class. Okay. I hope you all remember it, right? Insertion sort places a given element at the right position in the sorted list. So in the beginning, we compare the first two elements and sort them by comparing them. Then we pick the third element and find its appropriate position among the last two sorted elements. This process continues till all elements land in their proper position, right? So now we will see the program for insertion sort. Meanwhile, if you have any doubts, let me know in the chat box. Okay. Same as it is before. First, we used def keyword to create a user defined function. And this is the name insertion sort. And we have one parameter as array that we need to sort, right? Then we use the len function to get the length of the input array and store it in the variable n. Okay, we are storing the length of the array that we are using in the variable n. This tells us how many elements are in the list. Got it? This will tell us the length of the array that we are dealing with. We are storing that value in n. Moving on, we are putting up a condition, if condition. If n is less than equals to 1. So what will happen here is, if condition statements check if the length of the array is less than or equals to 1. If it is, the array is already sorted. Okay. If array is already, the size is 1 or less than 1, which means there is only one element in the array, right? So it is already sorted, right? So what it will do is, it will return this, right? If it is, the array is sorted, since an empty array or an array with one element does not need sorting. The function will exit and return nothing, right? As we have left it empty. Now we are using for loop. We use a for loop to iterate through the array, right? Starting from the index 1, the loop continues till n minus 1, right? Which means it processes each element in the array one by one, excluding the first, right? Because here we have used 1, not 0, right? Here we have used 1, not 0. Why is that? If you remember from previous class, we consider the first one to be already sorted, right? And we move on from the second. So that is what we are doing here. We're starting from the first element, not 0. Moving on, we have key equals to array with which index I. In this line, we store the current element, the one we are looking to place in the correct position in the variable key. Okay, this is the element that will be compared and potentially inserted to the correct position in the sorted position of the array. Okay, so as we did before, like we initialize the length of the array in n, same way we are initializing the element into the key. Okay, as you can see in the comments also, store the current element as the key to the inserted in the right position, right? Next line, j equals to I minus 1. Here we initialize a variable j with the value of I minus 1, which points to the last element of the sorted position portion of the array, right? The elements before the key, current key. Okay, while moving on to the next line, while j is greater than equals to 0 and key is less than array at element j, right? This line introduces a while loop that continues as long as j is not less than 0. Okay, which means it will execute till j is bigger than 0 and the key is smaller than the element at index j. The purpose of this loop is to find the correct position for the key that we have just calculated. Okay, the purpose of this is to find the perfect position for this key by shifting larger elements to the right. In the next line, we have array j plus 1 equals to array at index j. Inside the while loop, this line shifts the index at index j to the right by assigning it to array j plus 1. Got my point? So array j plus 1 is being assigned array j. The value of this is going into this. This effectively makes room for the key to be inserted. Now there is room for the key and it will be inserted to the sorted part of the array, right? Now in the next line, this line decreases j by 1 to continue checking the next element. As we are done with one element, right? One is more sorted now, right? So we need to move to the next element. Right now we need to jump over. For that reason, we are decreasing j by 1 to continue checking the next element to the left in the sorted portion. It keeps moving left until it finds the correct position for key or goes out of bound. Got it? Once the appropriate position is found, okay, this line inserts the key into correct position in the sorted portion of the array, right? You can make use of these comments we have written already. Insert the key into the correct position. At the end, we have taken an example array and we are calling the function and we run it. As you can see, it will be sorted automatically. This was our program for insertion sorting. Is there any question till now? See, more than almost twice the people have already submitted the attendance form that there are in the class. Okay, and the attendance form was open for almost 10 to 15 minutes. So I don't think I should open it again, right? Kindly do not spam in the chat box. Moving on to selection sort. Okay, now let us continue. First, we are defining a user defined function named as selection sort, okay, where it has two parameters, array and size. Okay, array is the list that we want to sort, and size is the length of the list, number of elements exactly in the array. Okay, first we have the outer loop. Okay, this for loop starts from the beginning of the array and iterates through each element. I'm talking about this. Okay, in this, the min index is initialized to ind, which means that at the start of each iteration, we assume the current element is the minimum element, right? Then we are moving forward towards the inner loop that we have. This nested loop iterates through the unsorted part of the array, right? From index plus 1 to the end of the array size, right? It checks if there are any elements, that is array j, is smaller than the current minimum index, right? If it finds a smaller element, it updates the min index to be j, as you can see in this line, if this condition is met true. Essentially, this loop finds the index of the smallest element in the unsorted part of the array. Then we are swapping the elements to the to sort the array, right? After finding the smallest element here, okay, we swap it with the element at index ind, right? This places the smallest element at its correct position in the sorted part of the array. We use the same process here also, I think, in the bubble sort. Meanwhile, if you have any questions, let me know, except for attendance part. Okay. Yes, after swapping, we have our case scenario. Okay, here we have array, and here we even have negative numbers. Okay, then we have the size selection sort. We are calling this function that we have created, and this is just print. When we run this program, this is the answer that we get: the array after sorting in ascending order by selection sort. These three programs, for bubble sort, insertion sort, and selection sorts, are the most important and basic ones. Other than that, we have two more, right? Merge sort and quick sort, which we are going to discuss. Is it clear till now? Shall I move on? Okay, so let us move on towards merge sort. Okay, you all remember merge sort, right? We discovered it yesterday. In merge sort, it is a divide and conquer algorithm. Merge sort first divides the list into two equal parts and then sorts the parts and unites them as a sorted list. So this is the what we do in merge sort. Okay, we discussed this in previous class. This is the list that we have. First we divide it and then sort it individually and then again reunite it to create a single list that is sorted. So now we are going to see how we can do that in a program, right? Moving on, first we have defined a function called merge, which takes four parameters. Okay, array, L the left index of the subarray, M the middle index, and R as the right index of the subarray. Okay, these are four array. Okay, which is the array that has to be sorted: the left index, middle index, and right index. Okay, then we calculate the size of the two subarrays that will be merged. N1 is the number of elements in the left subarray, right? You get the point, M minus L plus 1. So that will give us the number of elements in the left subarray. And N2 is the number of elements in the right subarray, right? M. Till now, is it clear? Now we are creating temp arrays. We are creating a two temporary arrays, L and R, to hold the elements of the left and right subarrays. As we discussed here, we need to create two arrays, right? Left and right. So for that purpose, now we have two subarrays, left and right, to hold the elements of the left and right subarrays respectively. They are initialized to 0 and their sizes are based on n1 and n2, right? Now we'll start copying data to temps array. These. For that, we'll use a for loop. These two for loops. Okay, these two for loops copy the elements from the original array into the temporary array, that is L and R. Right? The first loop fills L with elements from the left subarray, and the second loop fills the R with the elements from the right subarray. These two. After that, after copying the data from the main array to our left and right subarrays, we initialize three indexes: I for traversing L. Okay, I for traversing L. L was this L, right? J for traversing R. Sorry, this L. The subarray one. J for traversing R, and K for placing elements back into the original array. That is our original array, this one. Okay. Traversing we will do in this L and R. Left subarray and right subarray. For that we have initialized. Okay. Now we'll move further with while loop. This while loop merges two temporary arrays back into the array. Okay. So till now we are moving on this step. Now we are on the merging step. Okay. This while loop merges the two temporary arrays back into the array, the main array. Okay. It continues until we have traversed one of the array completely. Inside the loop, we compare the elements at current indexes of L and R, as you can see here. The smaller element is placed in the original array, right? And we increment the respective index I or j, whatever it is, based on the index, as well as the index k for the array, as you can see in this line, right? Then copy the remaining elements of L if there are any left. Okay, what this while loop will do is, this loop copies any remaining elements from the left subarray back into the original array in case there are leftover elements from the main merging loop. Then again we have while loop for right subarray. Same task for right subarray, right? Then we are uh, using this, defining a merge sort function. Okay, using the def keyword, we are defining a merge sort function which takes three parameters: array, L and R. The function will sort the elements of array between the indices L and R. If L is less than R, this condition checks if the left index L is less than the right index R. If this is true, it means that there are at least two elements in sort, right? Moving on to the next line, m equals to L plus R minus L divided by 2. This line calculates the middle index, that is m, right? We need this m, right? Middle index. This line will calculate the middle index m of the current subarray, right? After calculating this middle index, we will move on further. These two recursive calls sorts the first half. Okay, merge sort, we use this function, right? Yes, right. This first is for the second half and this is for the array, right? After sorting both halves, we call the merge function to combine the sorted halves back together, right? And now we have the driver code to the test above. We have an array and then we are calculating the length and initializing that to n, right? Print given array is, right? This blocks will initialize an array with unsorted values. We also determine the length of the array and print the original unsorted array, right? After printing the unsorted array, we have this line merge sort array, and this is taking arguments as array 0 and n minus 1. This line calls the merge sort function, passing in the array and its bounds from index 0 to n minus 1 to sort the entire array, right? Finally, we print the sort array after the merge function has completed. Print we are printing it using for loop. As you can see, this is the program for merge sort. The program might be a little complicated, but try to imagine this program alongside this diagram. This will help you in visualize the concept what we are doing here. Is there any doubt till now, or I shall move on to the next program that is for quicksort. Quicksort might be more complicated than this. If you have any questions, let me know, or I will move on after 30 seconds. Correct, right. 126 participants and we still have 17 likes. Why so? Hit the like button, come on. Let's move on to our last program for the day, that is quicksort. I hope you all remember what quicksort was. It was also similar to divide and conquer algorithm, but the difference was here we were choosing a pivot element in the array, right? So now we will see how we will do that in a program. Okay, first we are using def keyword to define a function which takes three parameters: array, that is the list that we have to sort, then low, that is the starting index of the subarray, right? And high, that is the ending index of the subarray, right? As you can see in the comments, choose the rightmost element as pivot. Okay, so to choose the pivot, here we select the last element of the array as the pivot. Pivot is the element around while which the partition will occur. Okay, as discussed earlier, we had to choose a pivot point, right? And I think it is also in this image. Yes, this was our example of quick sort, right? We had to choose pivot. First we chose 40, then we chose 70, this way. So here we have chosen a pivot. Now we are setting a pointer. We initialize a pointer I to track the position of elements smaller than the pivot. The elements that are smaller than the pivot. It starts just before the low index. Okay, this low index. That is why we have low -1. Moving on. Now traverse through all elements, compare each element with pivot. Right? For that we are going to use for loop. This for loop iterates through all the elements in the subarray from index low to high, right? And inside the loop we compare each element array j with the pivot using if condition. Okay, if element smaller than the pivot is found, swap it with the greater element pointed by I, right? If any element smaller than or equal to the pivot is found, we increment the pointer that we created above by 1. Okay, and then we will swapping the element at I with element at j if this condition is met true. Same way we have swapped in other cases, same we will swap here. Swap, we then swap the current element j with the element at index I. This effectively places all elements smaller than the pivot to left side of I, the left side. Okay. Then again we are performing a swapping. After the loop, we swap the pivot element. Okay. As discussed yesterday, we need to swap the pivot too, right? So after the loop, we swap the pivot element with the element at index I plus 1. Right? I plus 1. This places the pivot in its correct position in the sorted array. Right? And then we will return I plus 1. Return the position from where the partition is done. For that, return I plus 1. Now we are creating function to perform quick sort. Till now we were creating partitions, right? Now we will perform quick sort. Same as before, we have creating a function here and it is taking 3 parameters, array, low and high. Okay. If low is less than high, this condition checks if there are at least 2 elements in the current subarray or to sort. Okay. If low is less than the high, it means the subarray is already sorted, right? Moving on to the next line. If there are elements to sort, we call the partition function which sorts the elements and returns the index of the pivot pi. This pi. Okay, you can name it anything. Well, right now you can see it as pi. Then we are calling the function quick sort array low and pi minus 1, as pi minus 1 will be the highest point. And then we are again calling a recursive call on the right of the pivot. Okay, quicksort array pi plus 1 and then high. Now this is the use case. Data is the array or the list that we need to sort. Okay, print unsorted array and print data. This is our unsorted array. Then we have defined the size, and then we are calling the function that we have just created, quicksort, and passing these parameters, data 0 and size -1. When we run this program, this is what we get: unsorted array and then sorted. That was it. If you have any questions, let me know. In today's class, we have discussed program for bubble sort, insertion sort, selection sort, merge sort, and quick sort. Kindly try these on your own, okay, or at least go through them once. Even if you copy them, at least copy them once. It will stay in your memory, right? All you need to do is copy it and then save it in your VS Code or so. Just try to implement it once. See how the logic is made here, okay, so that it sticks around. Yes, you are right, Sabera. You are right. No issues. So that was it for today's class. If you have any questions, you can ask. We have completed all the programs that we needed. Before leaving, hit that like button. I see there are only 30 likes. Do not submit in PY format, submit in PDF or in GitHub repository. It depends upon the use case, that which is the most efficient algorithm. I would say merge sort would be the most optimized, efficient algorithm. We will talk about it on 18th. I'm not sure why the link is not working, but we will mark the attendance from the first part only, because I think the link is not working now. There is some issue. That was it for today's class. Thank you for joining.